Thanks, Ian, for your very kind introduction. Thank you, every one of you, to attend my seminar. Hopefully, it will be interesting and helpful for you. And we will have time to discuss. So the topic of today is the characteristic of reclaimed asphalt and how these characteristics impact in the asphalt recycling. I decided to focus my presentation only in one side of the recycling technology, that is the warm and hot side. I decided to keep for another time the discussion related on the use of reclaimed asphalt in cold techniques. Okay. Just a quick outline of my presentation. I will start to introduce a proposal for and why we need a characterization of reclaimed asphalt. I discuss and I will explore with you what is the concept of degree of binder availability and degree of binder activation. And I will spend some time talking about the diffusion of new bitumen in reclaimed asphalt bitumen, that, in my opinion, is the most important phenomena in the hot recycling. We will see some effect of recycling agent of reclaimed asphalt bitumen, and we will spend some time looking at some specific problem that we can face. Basically, I face it in my research activity, but I think it's something that everyone can face when the amount of REP goes up than 30%. So to what we can discuss, we can define high amount of reclaimed asphalt. We will discuss some practical limits and also some problems related with this particular choice. So, what is reclaimed asphalt? I think everyone knows. Basically, is the result of the milling operation, or sometimes, just to add more complication, is where the contractors send the let's say undeciderated or the wrong mixture. So basically, we have something that we can define like a black stone, that is a stone covered by the aged bitumen, something, and in general are the smaller particles, or what we can define as an agglomerate of stone or cluster. That is basically the biggest part. These are the biggest component of reclaimed asphalt and are again mainly the result of the milling operation. In addition, we don't talk about that, but we have to remember that this is one of the most important parts. We have another component, that is the water. The water that arrives from the milling process, or for the moisture, environmental moisture, or for the weather, the rain, and other conditions that can affect the REP if the stockpile are not covered. We will discuss a little bit more about that. So these are the elements that we have in the hand when we start to discuss about reclaimed asphalt. We will go back in this concept several times, but I like to underline very clear that one of the most important characteristic that we have always to remember about reclaimed asphalt is the heterogeneity. It's extremely complicated to have a stockpile of REP, and even in the same stockpile, same material. So the difference, the height difference is the most important, difference of the components is the most important characteristic of reclaimed asphalt. There is an example that I like to give to my student in my class, is that even in the same, I think I always say that, guys, even in the same road, if you have a part in a very flat area under sunshine, and we have another part in a tunnel, even in the same road, we may have two completely different kind of reclaimed asphalt if we made the pavement. Because in one case, we have all the weather conditions that we can imagine. In the other side, we have just one condition: no light, no rain, and same temperature. Just is an extreme example, but I think if you keep in mind that, you can understand how is the difference that we may have in the material that not only come from the same road, but come from, in some case, from different roads. What is the origin of the wrap? And again, this is another part that make this heterogeneity. The wrap comes from an old pavement, so let's say we can describe the generation condition are the traffic load, because if we have one kind of traffic load, we can have some kind of action in the bitumen, some kind of mechanical massage or let's say mechanical condition that in some way act on mainly on the stone part, but generally act. And we have to remember that there are different kind of aggregate and different kind of aggregate that interact in a different way with moisture that come from snow, rainfall, whatever. And we have different kind of binders in the surface layer, in the binder layer, or generally speaking in different part of the pavement that again has a different result when they face all the weather condition, temperature, so the aging condition. But we have also another element of difference that are the characteristic of hot mix asphalt. We may have several one if we move in different kind of wearing cores, and if we move vertically in the pavement. We may have OGFC, we may have split mastic asphalt, rubber asphalt, whatever. And now with different kind of aggregate, we have a very stiff aggregate and resistant aggregate in the surface, maybe limestone in the basement. So different aggregate, different size distribution, everything can be different. And this different element can be made more heterogeneous from the milling operation. The milling operation makes different size distribution in the wrap in function of the capability and the force of the milling machine, the speed, how depth we go in the milling. For example, if the two extreme, we can have like in this case a full depth reclamation with everything inside, or we may have a fractionated milling operation, or whatever you call organized milling operation, when layer by layer, when the road is milled, the pavement is milled layer by layer, and the material stored in different stockpile. And again, another variable are the pavement condition, the damage level. If we have something like that is a pavement with just aged material, we have something. If we start to have polishing, the aggregate condition changing, different rutting, it means that we have different behavior of the bitumen and whatever we have. So again, another level of variable. One more, even in this very chaotic ensemble of variable, we have also the storage condition and the storage time. If we keep the material covered, we will have less moisture inside that in the case of stockpile stored outside in the weather, under the weather condition. But also the time in the stockpile and the location or in the stockpile changes the characteristic, because if we have something on the top, it means that probably is there for very small time. If it's in the bottom, probably is there for a lot of time under high pressure, less change of temp, or maybe higher temperature, and again is something that can affect the characteristic of the wrap. How all this list of variability can impact the characteristic of our reclaiming asphalt in function of the use. As I said, we focus our attention on the hot recycling. How we make the asphalt mixture with wrap in the hot recycling, following the hot recycling technique. We have a plant that makes the material. In this case, we have some kind of Los Angeles test, if we can discuss. So we have abrasion, compression, and different action on the aggregate. And after that, we have the action of the roller compactor that gives another shear and pressure. if we have what we decided, we call it before, we name it before hot rock, we have probably only the effect of the temperature and some leaving or softening of the bitumen. I say probably because if we act with a very strong force and or the aggregate are weak, we may have also some breaking, some polishes, some crack in the aggregate. But generally speaking, we can decide that the main action is only the temperature. But if we have a cluster or agglomerate, all these action, friction, abrasion, compression, change the characteristic, the size distribution of the wrap, because we have the cluster divided not in the all fundamental component, but in several parts, and due to action of the abrasion and the compaction. And again, we have also the action of the temperature that in this case work in two ways. One, making the bitumen softer and maybe leaving, but also making weak the connection among the particle of the cluster and can increase the, let's say, the disruption of the agglomerate. And what we have that. In terms of the stability of the size distribution, I like this concept because we have to remember that, as I mentioned before, we have some changes in the size distribution. So we have to, for a good mixed design, we need to understand if the size distribution of our wrap is stable or not. Why that? Because if it is not stable, we may have problem in, we have changes. And every change that is not under control, in my opinion, is a problem. So if we're in the part of the wrap, there is a smaller one that we can again name black rock, we don't have so much problem in terms of size, the stability of the size distribution. But if we go in the cluster, the point that we have to keep in mind and the characteristic that we have to analyze is that we are not sure, or there is a risk that the final grading curve is not the one that we think, or maybe that we designed in the mixed design phase and we will not found in the construction phase. Why that? This is an example that I did with my student a few years ago. We took some particle of some wrap, we mixed it with natural aggregates, and we compacted in the Proctor compactor. As you can see, some of these clusters are not anymore retained at the 25 millimeter sieve. So basically what we found, mixing 30% of natural aggregate and 70% of wrap, we started with this size distribution, and we we had at the end this one. In this case, was studied to have this on purpose. So we had an original size distribution that was out of the minimum and the maximum size distribution, but after the compaction, we were able to have a little bit more fines and less coarse element, and we were able to bring inside of the standard requirement the size distribution. But this was something in the good way. If we don't keep correctly in account the amount of cluster that we have in our wrap, probably we may have the opposite, that instead occur a size distribution that in the origin is inside of the standard requirement. It can goes out, especially in the coarse part, and of course, changing the size distribution in the coarse has an impact also in the fine one. And I have to say that this is not a negligible problem, because this is a result of a study where I was involved during my time at University of Florida, and it was a project of Florida DOT to understand the effect on the final mixture performance made by the size distribution of what in the US they call interstitial component. Interstitial component is the fine part, is the name used for the fine part if you use the Bailey method for the definition of the size distribution. So basically is what is for us filler, stand, and small aggregate. Here, the project was to the project goal was to understand the behavior of the mixture, changing the original size distribution in the three ways, but all the size distribution analyzed were inside of the standard requirement. If we look in the right side of the slide, you can see how the different mixture behave in terms of fracture energy and failure strain. So some small changes that only, I underline, only in the fine part of the aggregate made, you can see a huge change in the fracture energy of the material and related in the failure strain. It means that only a very small change in the fine distribution change a lot the final performance of the material. And if we go back in this example, okay, this I say it was made in purpose to bring in the size distribution, but can you imagine if a change like that happened in a mixture, which kind of behavior we have? So it's very easy to set a very good mix in the mix design phase, and at the end, if we are not accurate in the control of the rep, we may have a very negative impact in the final performance. Okay, this is important. This is a concept that is important to understand. If we work with less than 20% of the rep, we are in an amount of rep that can induce a level of change that is inside of the variance of the test is something that is negligible. What we move forward and we go up of 20% with 30, 40, 50, and even more, as now is required by from a lot of agency, there is a very big risk that what we did in the mix design phase is not what we have in the field if we are not very accurate considering this element. A proposal to face this problem was made a few years ago by the Royal Technical Committee TC237, led by Manfred Parkle. And among the technical recommendation that went over from the activity of the technical committee, there was a recommendation on how to characterize the reclaiming asphalt, and especially there was one test inside of this protocol that was named fragmentation test, exactly designed to analyze the problem that I just described. The fragmentation test is a very simple test that consists in the evaluation of the material passing a control sieve before and after compaction. Following a French standard for aggregate, the rep is analyzed in different size classes, 2030, 4020, and 1014 and 15, just to have a different idea and to analyze more in details the size class where it's possible to have cluster. And it's performed at 3 different temperatures to keep in account the contribution of the bitumen. So basically, what consists the test? The test consists in take the wrap, check with control sieve, look what is the amount of passing, do the compaction with Proctor or maybe gyratory compactor, but the idea was to use Proctor, and again check the material passing on the control sieve. Why the proctor and say the why a control sieve? The idea when the test was decided was to have a very, very simple test in order to have something that can be efficiently used in the field. We cannot have in the quality control a test that gives us 100% of information but requires 1 week. Too much time. If we are doing the quality control in a paving operation, we need an information very fast. Otherwise, we are not in the condition to stop something that I don't say wrong. This test gives just an alert. The alert that say, be careful, the material that you are using is not the same that you tested in the mix design. Up to the field engineer to decide if this is just a minimum variation or if it's an important variation. And I show you some data related to the effectiveness of this test. You can see here during the round robin to validate the test, we're tested 2 different reps from 2 different parts of the world. And you can see here that 2 different reps gives different results in terms of coefficient of fragmentation at different classes. So these 2 reps, even if apparently are similar, they are not in function of the behavior after compaction. You can see here that changing the temperature, there is a change of the coefficient of fragmentation that is very similar at the 2030 in the class 2030, but is totally different at the smaller size at the class 510, and again is even different at 4020. It means that probably we have in this case a very stiff wrap that make very stiff bitumen that allows to have differences only at the high temperature. Just to show how it's possible to identify changes, we decided to validate the test to take 2 different material. One is a normal wrap that we took in the area here around Palma, and generally is a binder wrap, so limestone. And we took also some steel slag. And we tested 100% wrap, 50-50, okay, are not realistic, but the idea is that in some case you may have stiff aggregate, a blend of stiff aggregate, or a blend of also steel slag. Is in some part of the Italy are currently used for wearing cords. So as you can see here, if we have 100% wrap, this is the result of the analysis. But if we move for 50, same size distribution, if we move with 50-50, we have a change in the passing at the control sieve. That is even more if we are using only 100% steel slag. So what it means? It means that the test is really capable to identify changes in the stability of the size distribution, because steel slag, if you compact steel slag, there is almost no change before and after compaction, or too stiff. But if you compact different kind of wrap, maybe, and of course the value, this value changes in relation of the amount of agglomerate. The second point that we have to remember is the amount of bitumen that is available or can be available, and which kind of phenomena lead the blending. It could be a simple blending or a diffusion. In my opinion, the bitumen that leaves the wrap is not a lot. We did a test a long time ago when I was cooperating with EMPA, and we did a mixture with just natural aggregate coarse and fine bitumen with a very clear difference in the size distribution in order to have a fast separation with a sieve, and mixing without any bitumen added and recovering the bitumen, we found that we have almost no bitumen in the natural aggregate, and 8% of bitumen. We were analyzing just the fine part of the bitumen with the rep, with a lot of bitumen. In that case, we found 8%. So there was no no bitumen leaving. Of course, it's something that can change in the different condition of rep, in the different characteristic of rep. But something that is not. The other part of the bitumen, the other part of the blending can happen for diffusion. In a research work that I did together with my colleague at NTP, we used a double layer specimen with stiff bitumen on the top and soft bitumen on the end. We apply and we use the complex modulus as an indicator of the change of the performance. So we put the two layer in the DSR and we applied and same stress for a long time using the complex modulus as an indicator. And you can see here that this is the evolution of the complex modulus of the soft bitumen. This is the evolution of the complex modulus of the hard bitumen. This is the evolution of the full blending. So we took, so it's not a double layer, these are not double layer specimen, but just one. In this case is the full blending, 50% of that of soft, 50% of so hard and soft. And we have seen that during the time, there was an evolution of the complex modulus that was bringing the bitumen, the two layer, to a behavior that is similar to the one of the full blending. So the hypothesis, but of course there is a need of much more investigation on that. There is the hypothesis that during the time there is an increasing of the diffusion that at the end brings a full blending. I can give you more details but just for a matter of time, we were able to put together a law to predict the diffusion thickness, and is related, and everything is related with the complex modulus. But you can see here that during the time, the blended, let's say we call the blended zone, increases until there is not anymore B1, not anymore B2. So it means that the two layers of the coating of the new bitumen, time by time, step by step, goes inside of the old bitumen. This is later to consider how we have to design our hot mixture in function of the bitumen that we have in the wrap. Some years ago, a group of researchers, led by University of Nottingham, put some definition that was these three definitions: degree of binding activity, that is an index that indicated the minimum percentage of bitumen available. So the bitumen that is in the wrap that is still active to bind our aggregate. And the degree of binder availability is the amount of bitumen that could be available. Doesn't mean that is active, but is available, but doesn't mean that is active. And the degree of blending is the amount of the bitumen inside of the wrap that goes together with the fresh bitumen. This is a very complicated, simple to show, complicated to prove. This is basically the evolution. Again, there was a proposal from the SIB of RILEM in the protocol to try to have an estimation or an indication about the amount of available bitumen. This is called cohesion test. Again, very simple in order to provide a device that identifies differences very fast in the workplace. This is a very simple test. Is the wrap compacted without any bitumen additioned and compacted at different temperature, and look if there is possibility to have a specimen and how is the IDT stress of this specimen at test at 25 degrees. You can see here that again 2 different wraps. In this case, both were not able to give a specimen compacted at 20 degrees, but we were able to have a specimen at 70, and you can see that this is the level of IDT, but increasing the temperature, we have another level of resistance. It means that probably the bitumen in the wrap B is much more stiff than the bitumen in the wrap A, but as soon as we reach higher temperature, there is the possibility to mobilize this bitumen. And probably the amount of available bitumen is much higher in the wrap B than in the wrap A. You can see that it's probably softer, but there is less bitumen available. And again, to show how this test is able to catch this difference, we did with the same wrap, the same one, 2 specimens, and we aged artificially. Basically what we did, we put under the sunshine for 1 month and we boiled for 1 week just to force an aging, and we compacted at 70 and we did the test. Very load and displacement, nothing. But something that is easy to repeat and do. And you can see here that the aged one is definitely much stiffer than the original one, even if it is the same bitumen. So it's possible to catch some difference. And again, if we compact at 140, the difference is less, but there is a still difference between the aged one and the not aged one. Again, I don't see that this is something that can make problem, but it's for sure something that the field engineer has to consider. Again, we have to remember that the size distribution and the air voids can have an impact in this way to estimate. It is a little because we call estimate. These are some tests did by a task group inside of the Rhine MTC PAR, and you can see that different wraps, again, to show how the heterogeneity can play a role, gives different level of IDT tension in function of the size distribution. So we have some wrap that gives more or less a linear behavior in function of the compaction temperature, other that gives something like that, and other that is something extremely different. And again, you can see that this is related with the level of air voids in the mixture. So the size distribution of the wrap, again, affect the behavior. And we have to keep in account when we do this kind of estimation. And this is a general trend that more shows that there are a lot of difficulties to identify a common behavior, but if you get a lot of sources, there is the air voice that is reducing, the level of the air voice that goes down, how much we increase the temperature, that makes sense, but the IDT follow the temperature, but at one point, and makes sense because if the skeleton start to, there is some kind of plateau performance. But this is the reason because we can talk about estimation and not evaluation. So we have to really keep in mind that. If we move in the idea to use as much as possible of the available binder, we have to put in our mind that the bitumen that we have in the wrap can be organized in these categories. So we have the absorbed bitumen that doesn't go anywhere, and the fully aged bitumen that we can call unavailable bitumen. But beside that, there are bitumen that is still available, so it's not aged totally, so there is still some characteristic that can make it like an unavailable bitumen, or bitumen that has not the characteristic to work, but that can be activated. This is the area or the amount of bitumen where we can work to optimize or to maximize the effect of recycling, because how much we can activate of the bitumen that is aged, not active but potentially active, increase our degree of binder availability, and of course increase the let's say the amount of bitumen that we save. And this is the area where the recycling agents are working. Recycling agent is a word, instead. We can, of course, the characteristic of a recycling agent changes in function of the amount of bitumen that we have to treat, or basically in function of the amount of rep that we have in our mixture. If we stay in a very low, the original 20% or something like that, we don't have to, okay, we can, but we are not obliged to consider so much the rep, and we can work on the standard bitumen. If we go a little bit, a solution can be the soft bitumen. This is an investigation of the state of the art provided by Laurent Porot. And if we go after 30, it's common to use different kind of additive rejuvenator, fluxant, or whatever to make available and active the bitumen that comes from rep. It's hard to classify the recycling agent because there are a lot of patents, a lot of let's say secrets, but generally speaking, we have a recycling agent that works on breaking the asphaltene chains and again reduce the viscosity of the material. There are other recycling agents that breaks the asphaltene compounds, again looking with the goal to reduce the viscosity of that. There are also, and this is part of the recycling agent with bio-oil or bio that not only work on breaking and breaking the asphaltene chains, but also provide some oil that restore or bring back the level of the oil or the volatile. We have to remember very clearly that there is no, we call rejuvenation, but there is no rejuvenation. The aged bitumen is still an aged bitumen. What we can do, we can attack, let's say, the bad part of the agent, and we can mitigate the effects of the agent. But we have always an aged bitumen in the end. This is something that I think is extremely important to remember. If we look a little bit in the performance, we see that generally speaking, when we insert a recycling agent, we have an increasing of the penetration. So it means that this is a research that I found in the literature, doing a literature review, our work made in Germany, and it clearly showed that the bitumen with recycling agent become softer than the aged one. Again, another work in Germany shows that different level and different kind of recycling agent increase, reduce the softening point, the ring and ball point of the bitumen, and the aging bring back the condition of the bitumen in terms of softening point to the original one. So basically, recycling agents bring back, but gives still the same level of performance or the evolution of performance than the natural bitumen. A work made by Professor Canestrari in Italy shows also that, from a different point of view, but similar effect, that if we add a recycling agent, we are able to reduce the stiffness. So the G star of the different level of aging of the same bitumen are lower than the original one. So with the recycling agent, we reduce the stiffness of the bitumen. That's generally one of the main concerning related to the viscosity. Together with the viscosity, it doesn't allow the proper coating. And this is something that we have always remembered. This kind of evolution of the in terms of softening point and penetration point, in my opinion, is a little bit empirical, but is extremely important to keep in mind. Why? Because if the agency do as a quality control of the final mix or the bitumen of the final mix, they are only penetration and softening point of the recovered bitumen, we have to check something like that, because doing the recovering of the bitumen, we forced the full blending of the material, and at the end we have one binder that, if it's tested only with penetration and softening point, has to match the requirement, the original requirement. So even if it's not, even if it's a little bit empirical, this method is something that we have always to remember and always to check if the agency does a control on the bitumen only with recovering and doing softening point and or also softening point and penetration. There is another point that we have to remember. If we go very high in the level of the reps, or the so-called high amount of rep mixture, is the quality of the aggregate. It is extremely important because the rep is not the same, and the rep that comes from different layer cannot go everywhere. So if we have a rep that comes, a reclaimed asphalt that comes from wearing cores, this material that can go everywhere, because the aggregate can satisfy the most restrictive requirement in terms of abrasion resistant and polishing resistant. But if we have a rep that comes from binder layer and then base layer, this rep cannot go everywhere, or this rep cannot go in the wearing cores. This is something extremely important, especially if we have reclaimed asphalt that is ended, managed, engineering, whatever you would like to call. So if we have our stockpile and we sieve, we mill in order to put a very precise size distribution and to check under control. So if we manage, if we handle the rep, at the end we have to be very sure that is in this ending operation there are no, we have to understand which kind of aggregate goes in the lower layer or which kind of aggregate goes in wearing cores. In my opinion, a selective milling operation is required if we think about high amount of rep. Generally speaking, there is a need of at least 40% of very resistant aggregate in wearing cores. So if we go up in terms of the rep, we need to guarantee that this 40% is always present. Otherwise, we have a problem with the friction between tire and pavement. A very simple test that I propose, we are working to normalize, is to check in a very simple way. Hydrochloric acid, is a very, very quick test and very easy to. If we put in the hydrochloric acid limestone, that is an aggregate that we can find in binder layer and base layer, you can see that there is a very quick and evident reaction with the hydrochloric acid. And if we put basalt, there is nothing. Same for steel slag. So this is something that can be done very fast in the field, because the only thing is take out the bitumen with a solvent, even in a brutal way, take an aggregate and put inside. So this is a very good, in my opinion, good and fast method to check if there are too much or if there is limestone in a wearing course material. Again, considering the stability of the size distribution, when we face the challenge to put together a mixture with high amount of rep, we have to check if we are able to obtain the size distribution, because it's not always guaranteed that with the size distribution of the rep we can reach the required size distribution due to the size of so maybe there are too much cores, not enough cores, or whatever. So we have always to remember to check if we can reach the required size distribution. I tell you, I was in a project that I had, I was so excited to have the chance to put a lot of rep and say, oh, we can do with 70% of rep, 80% of rep. But when we check it, the final size distribution, even if the amount, we are totally out, because the size of the rep didn't allow to obtain the required size distribution. So it's something that we have always remembered, especially considering that the size distribution of rep cannot be 100% stable. Another suggestion or proposal, something that I'm working right now in a research project, is how to guarantee the quality of the bitumen if we have an high amount of rep. If we have an high amount of rep, it means that we have a lot of bitumen that comes. And of course, we like to have a lot of bitumen coming from rep. This is one of the reasons. So we needed to put ourselves in the condition to answer what we are able to do with the requirement in terms of performance. Or if we use a polymer modified bitumen, are we sure to have the right amount of active polymer in our mixture? Because generally what can happen that the aged bitumen or the polymer modified bitumen has exhausted polymer inside that are not active, not able to give us what we are looking for. So one idea is to use a very high level of polymer bitumen, so what is called a hyper-modified bitumen, in order to have, of course, it's something that has to be checked in terms of design, to have a blend between hyper-modified bitumen and exhausted polymer, in order to have to match the minimum requirement in terms of high polymer that provide us the performance that we are looking for. Especially, this is extremely important if you are thinking to do a wearing course, or if we are thinking to do, as now is common to have as a question from the agency, to do polymer, OGFC with rep. Just in this case, from the experience that we have, is important the dosage, and probably the dosage made by only penetration and ring and ball is not the most appropriate one. Caution is required. These are some results that we got from a multi-stress grip recovery test at different level of recycling agent following a dosage made by a method based on penetration, ring and ball, and viscosity. So we can see that only on that, it seems that a higher amount of recycling agent is not effective. So of course the recycling agent is effective because we have a big recovery in performance in all cases, but it seems that if we have a higher amount of recycling agent, there is a decreasing in the performance, if you can see in both. But if we look in the performance of the mixer, in this case, we analyzed the fracture behavior following the HMA fracture mechanic approach defined by Ray Roque at University of Florida. You can see that if we analyze the mixture and we consider that this is the level of requirement, of course, this is the virgin mixture. If we had 40, 50, even 70% of rep with recycling agent, in terms of performance, we are in a very good way, in a very good shape. And more recycling agent we put, higher performance we have in terms of mixture. It means that probably if we analyze only the bitumen and if the dosage is based only in penetration and in a ball, there is something that we are not able to catch, probably. So my proposal is that if we go in the mixture with high amount of rep, it's important to have a rheological-based dosage process. This is something that we have to think about, and we have, of course, research is required, and we need to work on that. So I use a lot of more time of what was possible. I hope that I not bored you, and what I did is something useful and interesting for you. So now I am available for your questions, comments, and criticism, of course. Thanks a lot for your time.